Hey everybody, I want to show you today how to create a discrete distribution chart that you can use to find your probabilities. So I'm going to begin a blank project and just going to think for a minute. I'm going to toggle off my navigator. And so column C1 is where I want my X values stored. Remember, X is just my outcome. So I'm going to come up to Calc, and I want it to make pattern data, and I just want a simple set of numbers. And I want to store the pattern data in that first column, and I'm going to run it from 0, and we'll say that I have 20 observations. So from 0 to 20 in steps of 1. The value, each value is listed only once. Number of times to repeat is just once, and I say OK. So what you'll see is that Minitab has simply saved me the trouble of typing 0 through 20. Now I'm ready to get my probabilities. So I'm going to go to my probability distribution, and for the purposes of this table, you want the probability density function because that returns the value, the probability for a single value of X. And what I want Minitab to do is to fill in the probability of all 20 possible outcomes. So I am not going to have a single value. I want it, my input is going to be my column of values, and those are my X's. And then I'm going to pick my binomial distribution. I had 20 trials, and we'll give it an event probability of 0.15. And I want it to store the probability density values in a column. So I've told it where are the X's it needs to use, what type of distribution do I need to use, and then trials and event probability. And I say OK. And you'll see that what Minitab has given me, come on, is my probability, my binomial probability density function for X. So what that means is that the probability of exactly 4 is this. The probability of 2 is this. And if I want the probability from 2 to 8, I could simply take those values and sum them up. So it keeps you from having to work with the cumulative function, and it's just kind of a shortcut. I can also come in, go back to Calc, go to my probability distributions, use my PDF function again. It's going to be the values in X, except this time I'm going to pick a Poisson distribution with a mean of 9, and I want to store them in a column. I say OK, and now it's given me the Poisson PDF for these values of X that are here in column C1. So you can do this with any of your discrete probability distributions. Hopefully this little trick helped, and thanks for watching.